Guys, if you are new to my channel, then please subscribe to this channel and click the bell icon to get the notification for upcoming videos. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about what do you mean by error, bug, defect and failure. And this is an important interview question, guys. So if you are new to the software testing industry, or if you are a fresher and if you go for an interview, so people or interviewer might ask at the time of interview that what do you mean by error, bug, defect and failure, and what is the difference among them. So generally, some of the terms we use interchangeably in the software industry. So that's why people are getting confused while answering this question. So let's talk about them in detail. So let's talk about error first. So what is an error? So error is a mistake made by developer while writing the code. Or in other words, I would say error is a programmatical mistakes done by developer while writing the program. So what are the different types of error we may face while writing the program? So we may have syntax error. Let me just write some of them. We may have syntax error. We may have compilation error. Compilation error. We may have runtime error. And we may have logical error. So these are the different types of errors we may face while writing the code, guys. So if you talk about syntax, so let's say suppose I want to print something in the code. So suppose I want to print hello, and here I have missed the last parenthesis. The second parenthesis I have missed in the code. So that leads to syntax error in the program. If you talk about compilation error, so if we made some mistakes, like syntactically, if we made some mistakes in the code, or if we have written some wrong statements in the code, so that leads to compilation error in the program. So we are not able to compile our program. If you talk about runtime, so in runtime, what happens is we are successfully able to compile the code, but we are not able to run the code because of runtime error. So what are the examples of runtime error, guys? So suppose we divide any number, by 0, that leads to runtime error. Or another example could be, suppose we have given reference of any missing file in our code, that leads to runtime error. Or suppose we are calling any invalid statements, invalid function in the program. So because of that, we will get runtime error. So these are the different examples of runtime error, guys. So in runtime error, what happens is we are able to compile the code, but we are not able to run the code because of runtime errors. And if you talk about logical error, guys, so let's say we are developing a software, and for some functionalities we have written some logic, and if we made some mistakes there, then we will not get our expected outcomes. So that is logical error. And these two, runtime error and logical error, leads to defects in the software because we are not getting the expected outcome. So that is defect, which we'll discuss next. So these two leads to defect in the software. So if you talk about so this is all about error, guys. If you talk about bug and defect, so these two terms are used interchangeably in software testing, guys. Somewhere we are using bug and somewhere we are using defect. It depends on companies to companies and project to project, guys. And in some tools we used to say bug, and some tools we used to say defect as well. So these two terms are using interchangeably. But what do you mean by bug and defect? So if you see any deviation or difference in the software with respect to expected result and actual result, if you see the difference in actual results and expected results, or expected outcomes and actual outcomes, so that is nothing but the bug or defect. So let me just give you an example. Now developer is developing a software, guys. Now unit testing is done. Now they have given us the software for testing purpose. They have released a build to this testing team. Now in this software we are testing the login screen. So we have username, password. We have two fields, username, password, and submit button. The build came to us for testing that software, so we are testing it. So we are testing the login screen. Here we have username and password, and this username should take, as per the requirement, it should take alphanumeric values. Alphanumeric values, guys. Alphanumeric values. But while testing it, it is taking only alphabetical values. So that is not as per the expectation. So that is a defect. So what we will do, we will revert to the development team. We will raise a defect. In that case, we will raise a defect because our actual outcome is not as per the expected outcome. So we will raise a defect in defect tool. So that is a defect. Now what about failure? Last term we have here failure. So when we release the software to the end user, when we release the software to client, and if they face some problems, they face some issues like the software is not as per their expectations, so that leads to failure in the software, and end user will use it, or while testing the application they will face some issues or problems, so that leads to failure in the software. Now how do we relate error, bug, defect and failure? So let's say this is error, and bug, as I have discussed earlier, we are using interchangeably these two terms. And here we have failure. Now error leads to the bug and defects in the software. Bug and defect leads to failure. So error, we have spoken about runtime error and logical error. Because of that we got the defect, and because of the defect, let's say suppose we are not able to catch that defect in testing environment, and we have released the software to the customer, that leads to failure in the software. So this is the relationship between error, bug, defect and failure, guys. So this error belongs to developer, this belongs to tester, and this failure belongs to customer. Yeah, so this is the difference between error, bug, defect and failure, guys, and this is how we can relate these terms. And if you like this video, please share it, and if you are new to my channel, then please subscribe it, guys. So this is all for today. Thank you so much. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about defect report in testing lifecycle. So as we all know that we have different stages in software testing lifecycle, like we have requirement analysis, test planning, test design, test execution, defect reporting and test closure. So these are the various stages in software testing lifecycle. So we have already covered requirement analysis, test planning, test design, test execution, and today we are going to talk about defect reporting. So guys, if you haven't watched the previous videos, then please go and watch those videos first and come back to this video. So as part of this video, I'm going to talk about what is a defect, what is defect report or defect reporting, and we'll discuss about what are the various reasons for which we used to get the defect in the application, and what are the various fields are there in defect report template, and at last I'll show you the real-time template of defect report as well. So let's get started. So let's talk about first what is a defect. So whenever we test any application, guys, and if any functionality is not working as expected, so that means there is a defect in the application. So let's say we are testing any application where we have let's say we are testing the login functionality where we have username, password field, and we have sign in button, and while entering the user ID, correct password and click on sign in button, we are not able to log in into the application. So that means there is a defect in the application, correct? So there is a defect in the application because our expectation is we should get the login page, we should get the home page, or we should get the successfully we should be able to log in into the application, correct? Now we got the defect. Now that defect has to be reported to the development team. So how we are going to report to the development team, correct? So there are two ways we used to report to the development team. So the first way is, like some of the companies are using the Excel sheet. So there are various fields in Excel sheet, or you can say in defect report template. So these are the different fields available in defect report template, which talks about the details about the defect when we raise a defect. Like we have defect ID, we have summary of the defect, we have status, and we have priority, severity. Like that, we have various fields in defect report template, guys, which we are going to discuss in coming slides. So this is one of the way to report the defect to the development team. Another way is using bug tracking tool. Like we have Jira, Bugzilla, PR tracking. So we have various tools available in the market using which we are going to assign the defect to the development team. So this complete process is called defect reporting, and this template is called defect report template. And we have the same fields in bug tracking tool as well. Like it generates the unique ID, which is defect ID. We have summary of the defect we have to mention over there. We have steps to reproduce. Like that, we have various fields in bug tracking tool as well, which we are going to discuss in coming slides. Now question arises here is why we are getting the defect in the application. So there could be various reasons. So first reason could be missing requirement in the application. So let's say we are developing a website, and that website should have home page, dashboard, admin page. Let's say home dashboard page is there, admin page is there, some other pages should be there, and along with that we should also have about us and contact us page should also be there as per the requirement. But while developing this website, developer misses this contact us page. So that means there is a defect. We can raise that as a defect. We have to raise that as a defect in the defect tracking tool or defect report template. So this is one of the reasons, guys. Another reason could be wrong implementation of the requirement. So let me give you an example. Let's say we are developing a website. The website name is abc.com, and while launching this URL, we should get two buttons over here. One is sign in page, which is for the registered user. When we click on this sign in, we should get the user ID, the login page, user ID, password field, and sign in button. We should get the sign in page. And while clicking on this sign up, right, and this is sign in. So sign up is for the new user, so this is complete user registration page, guys. So what happens here is, let's say while clicking on this sign up, we are getting this login page only, correct? So this is wrong implementation of the requirement. Another reason could be while getting the why used to get the defect is misunderstanding of the requirement. Misunderstanding or misunderstood the requirement by the developer. So let's say, as per the requirement in the application, the logo of the application should be displayed. The logo of the company or website should be displayed at the right side of the page, on every page of the application. But what happens is, while testing the application, we got that the logo is displayed at the left side. So that means this requirement is misunderstood by the developer. While developing the software, they developed this logo at right side of the pages, right? So we have to raise that as a defect. So these are the various reasons, guys, we used to get the defect in the application. Now let's talk more about the defect report, like what are the various fields are there in defect report template, and at last I'll show you also like the real-time template as well. First, let's just recap like what we have discussed so far. So if application is not working as expected, we can report that as a defect in the defect report. And what is defect report? A defect report is a document that has concise details about the defects are identified, what action steps make the defect show up, like reproducible steps, and what are the expected results instead of the application showing error while taking particular step-by-step actions. So basically defect report is a document where we talk about different details about the defect. We have to mention like defect ID, summary of the defect, status of the defect, and what is the reproducible steps, like what are the actions which we are going to perform to get that defect, correct? Defect reporting, defect tracking, and status tracking is called defect management. So the complete process is called defect management. Some companies use manual process like Excel worksheet, which we have discussed, and some companies use tool based process for defect management. So some of the defect management tools like Bugzilla, Issue Tracker, PR Tracker, and Jira as well. Jira basically is a project management tool, but we can raise the defects over there. So it's kind of complete project management tool. So this is the defect report template, guys. We have various fields in defect report templates, like we have defect ID, summary, detected by the tester who found the defect, detected date, assigned to, severity, priority, status, build version. So let's talk about, let me just show you the real-time template. So we'll discuss about various fields in defect report template as well. So this is the defect report template, guys. So here you can see we have various fields like defect ID. Defect ID is the unique ID which we need to make while logging the defect. Okay, so here you can see defect underscore 01. So this is the unique ID. For defect 2 we have defect 02, defect underscore 02. So this is the unique ID. While logging the defect in the defect tracking tool, also it generates the automatic defect ID when we log any defect in the defect tracking tool, like Jira. When we log in the defect, we used to get the defect ID. Now the second column is login summary of the defect, like what is the description of the defect or summary of the defect. Like login functionality is not working. Here I have mentioned like login functionality is not working. And third column is detected by. So who is raising this defect, who raised this defect? So here I have mentioned tester underscore A. Tester A found this defect, and the date on which we got the defect, and assigned to. So assigned to, initially when we raise the defect, when the status is new, so it is assigned to that particular tester, and when we open that defect, so it should be assigned to any developer. So here I have assigned it to developer underscore A. Developer A is assigned to this particular defect. And severity and priority. So here we have high severity and high priority, correct? So what do you mean by severity? Anyway, I'm going to talk about them in detail in separate video, but let me just talk brief about what is severity and what is priority. So when we talk about the seriousness of the defect, so that means it is severe defect. Okay, so like we have to give some severity to the defect. Like we have different ranges, like high, medium, low. So if it impacts the functionality of the application, so that means severe defect, correct? And we have to assign some values like high, medium, low. So in this case we have login functionality. So login functionality itself is not working, so that means it impacts the impact of this defect is very high because it impacts the functionality. So here we have given high priority because we cannot move further for the testing. What is priority? So this is importance of any defect. So this defect is very important. Login functionality is not working, so this is very important to fix by the development team, correct? So this is prior defect. I mean we should assign this as a high priority defect, because until unless if we don't fix this, then we cannot move ahead for the testing, right? And the next column is status. We have open state over here, like this is current state of the defect is open state. Now it is assigned to any developer. Now once developer is fixed this defect, they will make it as fixed, correct? Now later on they will make it as retest. Retest means they will assign to particular tester, so we need to retest that defect, and later on once we retest, we have to make it as closed. If it is working fine, closed. If it is not working, then we have to make it as reopen. So there are various states are there, guys, for a defect, which we are going to discuss in defect lifecycle. Probably in the next video I am going to talk about defect lifecycle. Next video I am going to talk about priority and severity, and later on we'll discuss about defect lifecycle, so that you can understand better. And the next column is build version. So here this is the build on which we have tested this application, and we got the defect version 1.5. Module is login module. Next one is what is the environment. So we have various environments, like we have test, development environment, UAT environment. So for this particular defect we got on test environment. So here I have mentioned as test. Functional defect type, what is the type of the defect? So here we have let's say we have functional type or non-functional or performance. So we have various defect types as well. So here I have mentioned functional type because this is related to the functionality. Reproducible, whether we are able to reproduce this defect or not. So here I have mentioned there are two values, yes or no. So here I have mentioned as yes because this issue is reproducible. Sometimes it is kind of incident we are not able to reproduce that defect, so we have to mention it as no, but we have to take the screenshot in that case as well to give the evidence to the development team for further investigation. Reproducible steps. So here we have given the complete steps like how we got this defect. So like launch URL abc.com, enter valid username, enter password and click on sign in. And what should be the expected result? User should be able to log in, correct, after following these steps. But what happens is user is not able to log in. Nothing happened when clicked on sign in button. So in some of the defect report templates, expected and actual results are not there, but in some of the templates the actual and expected results are there in the defect report template as well. So after clicking on sign in button, we should get the login page, we should get the home page, right? User should be able to log in into the application. And we have at last comment column as well. So if you have any remarks or comments, so we have to mention in this particular column. Now let's talk about the next defect. So here I have given defect _02. Logo of the company is not correct. So the summary of the defect is logo of the company is not working, which is detected by tester 2 and on this particular date and assigned to developer C. And this is the priority and severity. So here we have low priority and high severity, guys. So why it is low severity and high priority? So why it is low severity? Because it does not impact the application functionality, correct? So that's the reason I have given as it as low. And high priority because logo is very important, right? That represents the company, that logo. So if it is not correct, so that means that is high priority defect. That has to be fixed as soon as possible. And this particular defect, the status of the defect is closed. So like that we have to mention the status as well. This defect has been fixed and closed. And we have build version, we have module. Here you can see the environment on we got in UAT environment, and defect type is functional, like this. So this is what about the defect report template, guys. We have various fields in defect report template. So if you have any questions related to defect report, please let me know in the comment box, and in the next video we are going to talk about priority and severity of a defect. So thank you guys for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect priority and defect severity. And this is an important interview question as well, guys. So in the last video I talked about what do you mean by defect, what is defect report, what is defect reporting, and I have shown you the real-time defect report template as well, where we talked about what are the various fields in defect report template. So let me just recap what we have discussed so far. So whenever we test any application, guys, so let's say this is my application under test. Whenever we test any application and if any functionality is not working as expected, so that means there is a defect in the application, right? If any functionality is not working as expected, so that is a defect, and that defect has to be reported to the development team to get it fixed by the developer, correct? So how we are going to assign it to the developer, how we are going to report it to the development team? So there are two ways which we have spoken about in the last video. So the first one is some of the companies are using Excel worksheet to report the defect, to raise the defect and report it to the development team. So we have various fields which represents the defect, correct? We have various fields in defect report template. And the second way is using bug tracking tool. Using that we can raise the defect and assign it to particular developer. So these are the two ways, guys, and we have spoken about various fields in defect report template. So we have ID of the defect, we have summary of the defect, the date on which we raise the defect, steps to reproduce, status of the defect. Similarly, we have two more columns. We have priority and severity. while raising the defect, we have to assign these two values as well. We have to give values of what is the priority of the defect and what is the severity of the defect, correct? And the similar way, while assigning the defect, while tracking the defect using bug tracking tool, while raising the defect, we have to give these two values as well, priority and severity. And there are three ranges of values generally we have: high, medium and low, for both priority and severity. So this is the topic for today, guys. So basically, what do you mean by priority? Whenever we you might have heard like high priority defect or high severity defect. So what do you mean by that, correct? Which we are going to discuss, and I'm going to give you different examples like high priority, high severity, low priority, low severity, medium priority, like that. So we are going to discuss about different examples as well. So let's talk about what do you mean by severity first. So basically, severity defines the impact of the defect, like how severe the defect and how it impactful, right, to the application which we are going to test. Basically, it talks about the seriousness of the defect, like how seriously it impacts to the application, correct? So that is nothing but the severity. And as we have discussed, we have three ranges: high, medium and low. If you say like high severity defect, so that means it has high impact on the application. If you say like high priority, so that means we cannot go further for testing, like it has a lot of impact on the application, kind of a blocker issue, correct? So that's how we are going to assign like high, medium and low. Low has low priority, which has low priority, and medium has the medium priority, correct? As we it indicates like high, medium, low. If we talk about priority, what do you mean by priority? So basically, priority indicates the importance of the defect, like how soon the defect should get fixed, how soon the defect should be fixed, correct? So again, we have three ranges in priority: high, medium and low. If you say like high priority, so the impact of the defect might not be that serious, okay, it might not be a serious issue if you see the functionality wise, but the priority of the defect is very high, and it could be like high severe bugs as well, high severe defect as well. So priority means, if you assign like, if you say like high priority defect, so that defect should be fixed as early as possible. Similarly, we have medium and low based on the priority. So priority defines the, basically it defines the timeline of to fix the defect, and severity talks about the impact of the defect on the application. Now let's talk more about priority and severity, guys. So let me just recap what we have discussed so far. So severity defines how impactful a bug can be to the system. It can values either high or medium or low, specifies the seriousness of the defect. If you talk about priority, so priority indicates how soon the bug should be fixed. It can values either high, medium or low, specifies the importance of the defect, which we have discussed, guys, or the functionality. Okay, so the defect are fixed based on priorities. So whenever we say like high priority defect, so that should be fixed earlier. If you say like medium, so it depends on like how soon it should be fixed, correct? So we have three ranges for priority and severity. Now let's talk about the different examples of priority and severity, guys. So let me just draw a table. So let's say here we have severity, we have defect priority, and here I'll give some examples. So let's talk about high severity and high priority defect. High severity and high priority. So what are the examples, guys? So let's say we are not unable to log in into the application, unable to log in. So let's say we are testing a website and we are able to launch the URL, and while entering the username, password and click on sign in button, we are not able to get the home page. We are not able to sign in into the application, correct? So that is an example of high priority. Why it is high priority? Because this is the importance of defect is very high, correct? This has to be fixed because this is kind of blocker issue, we cannot move further. So that's the reason we have assigned it to high priority. And high severity, the impact is more, correct? The impact is lot because we are not able to log in into the application, so we cannot test further. So this is an example of high severity and high priority. Another example you can say high priority, high severity is, let's say while launching any website, and we are getting 500 internal server error or 404 page not found. So these are the examples of high priority and high severity. Again, why it is high severity? Because the impact of the defect is very high, because we cannot launch the application itself, because we are getting 500 internal server error or 404 page not found, correct? So severity is very high. And why priority is very high? Because this defect is very important to get it fixed as early as possible, because until unless if it is not fixed, then we cannot move further for testing, correct? So these are the example of high priority and high severity. Now let's talk about low severity and low priority defect, guys. So any spelling mistakes on the web page. So let's say we have a website, and at the end of the page, end of the website, or end of the page, we have at bottom we have some misspelling mistakes. So that could be an example of low priority, because low priority means it is the spelling mistakes at the end of the page, right, at last page, and that too at the bottom of the page. So that it does not have that much importance, correct? And why it is low severity? Because it does not have any impact to the application. There is no impact if you talk about the functionality wise, correct? So that is an example of low priority and low severity, any spelling mistake. And let's say spelling mistake is on front page, on maybe login page, we have at bottom we have some spelling mistake. So that could be an example of medium priority, but still it will be low severity because it does not have any impact to the application, guys. So this is an example of low severity and low priority, and low severity and medium priority. Any UI defects also, that could be an example of low severity, any UI examples, but priority may vary from low to high, any UI defects. Now let's talk about medium severity and high priority. So let's say we are testing inbox of Gmail page. Okay, so we have different emails over here in inbox. Okay, and at a time we are able to delete only one email. At a time, but while selecting all the emails we are not able to delete that. So this is an example of medium severity. Why it is medium severity? Because we are able to test the delete functionality, however we are able to delete only one email at a time. So that's the reason it is medium severity. But why high priority? Because we might need to delete all the emails together, right, all the emails at one time. So that is an example of high. So that's the reason we have assign it as high severity, high priority defect, correct? So this is an example of medium severity and high priority. Now let's talk about low severity and high priority defect, guys. High priority. So logo of the company is incorrect. If logo of the company is incorrect, so that means that is high priority defect, because logo represents the company. So that is high priority defect. Low severity because it does not have any impact on the application. Another example could be for this, like high priority, low severity. Let's say logo is as per our expectation, like as per business requirement, it should be at right side, but developer developed at left side. Okay, so that is another example, because as per the requirement it should be at right place. So that is an example of high priority and low severity defect. So these are the various examples of priority and severity, guys. So if you are not able to get it, then please let me know through your queries. You can comment it in the comment box, and like this video, share it, and if you're new to my channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much for watching, and in the next video we are going to talk about defect lifecycle. So thank you guys for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect lifecycle, and this is an important interview question as well, guys. So whether you are doing manual testing or automation testing, you should know what is a defect lifecycle. So basically you should understand what are the various stages of a defect. So guys, earlier we have spoken about what do you mean by defect, what is defect report template, and in the last video we have spoken about what is defect priority and defect severity. So today we'll focus on what do you mean by defect life cycle. So let's get started. So defect life cycle, also known as bug life cycle, is the journey of a defect cycle which a defect goes through during its lifetime. So this is also known as bug life cycle. So defect life cycle or bug life cycle is the journey of a defect basically. So it goes through various status, correct? So while talking about defect report template, guys, we have spoken about status column. So when we raise the defect, we have various stages of a defect, various status of a defect, right? So when we raise for the first time, so the status of the defect would be new, and then when it is assigned to any particular developer, so the status of the defect would be open, and then they will work on the defect. So they will make the status to fixed, and they will assign it back to the testing team, and the status of the defect would be retest. So these are the various stages of a defect, guys, various status of a defect. Whether we are logging the defect in the manual using manual process, using Excel sheet, we have a status column. There we'll change the status of the defect every time when we work on the defect. Any team when they work on the defect sheet, right? Or using any bug tracking tool also, so we have to change the status accordingly. So this is nothing but the various stages of a defect, guys. So this is defect life cycle. So defect life cycle is cyclic process which describes how a defect or bug passes through different stages, from the identification of defect stage to the fixing of the defect stage, correct, to the fixing stage. It begins when a tester finds or logs a bug, and it ends when bug is fixed. So this is nothing but the defect life cycle, guys. So it goes through various stages of the cyclic in the cyclic process, from the identification of the defect to the fixing of the defect. Now let's talk about defect life cycle in detail, like what are the various status of a defect. So whenever we test any application, and if any functionality is not working as expected, so that means that is a defect, right? So we have to raise that defect in the Excel worksheet if you are following the manual process or using bug tracking tool. So what is the first status of the defect? So the first status of the defect would be new. Now we have raised the defect. Now we have to assign it to the development team, right? So it will be fixed by the development team using any particular developer, right? It will be fixed by any particular developer. So the status of the defect would be open when we assign it to any particular developer. So the next status is open. Now they will work on the fixes, they will work on the defect, and they will fix the defect. So the status of the defect would be fixed, and they will assign it back to the testing team. Now it is our responsibility as a tester. We have to rework on the defect, we have to retest the defect. So what is the status of the defect this time? At this stage, retest. Now while retesting the defect, if we find that if defect is not working as expected, if it is not working as expected, so we will reopen the defect. We will reopen the defect and assign it to development team. So the next status is reopen, and we will assign it to development team. So they have to rework on their fixes, and once again they will fix the defect, they will make the changes to their code, and then they will assign it back to testing team. Again we have to retest the defect, and if it is working this time, if it is working as expected, so what is the last status of the defect, guys? If it is working fine, then we will close the defect, which is the last status of the defect. So this is the complete defect life cycle, guys. Apart from this, we have some other status of the defect, other statuses as well. Like if they are not accepting the defect, if developer is not accepting the defect, so they may reject the defect as well. If they say that defect is, if they not accept the defect, so they will reject the defect. So the status of the defect would be rejected. And then again we have to like follow whether it is really a valid defect or not. We have to assess that, right, whether we have logged the correct defect or not. In case if you find that if it is valid defect, then we have to showcase them to the steps to reproduce, and they will make it as again open, right? We'll assign it to any particular developer. But in case if they find that if a defect is not valid defect, so they may reject the defect as well. Another status of the defect would be duplicate. If any defect is matching with any previous defect, if any defect is matching with any previous defect, so the developer will make it as duplicate defect. And we have one more status, deferred status. So if any defect is not that much important to fix in this particular cycle, so we may fix that into the next cycle. So that's why we have another status called deferred state. Now one more status we have, guys, not a bug. So if any defect does not impact the functionality much, right? So we have another status, not a bug. We have another status called not a bug. So these are the various stages of a defect life cycle, guys. So this is complete defect life cycle. Now let me just recap what we have discussed so far. So what are the various status we have discussed so far? So what is new status? So new defect is reported is called new status. We have open state, right? Open status of a defect. So the developer is currently working on the defect, that is open state. What is fixed? The code changes are completed and the defect is resolved, that is fixed status. Deferred, developers will fix the defect later in the next cycle, so that is deferred status. Duplicate, the defect is same like one of the previous defect. When previous defect is fixed, it is also fixed, so that is duplicate defect. Retest, the tester starts the task of retesting the defect to verify if the defect is fixed or not, so that is retest. Rejected, developers did not accept the defect, is rejected defect. Close, after retest, if defect is working correctly, so that means that is the status of the defect would be close. Reopen, after retest, if defect is still exists, then we reopen the defect. And at last we have not a bug, if defect does not have an impact on the functionality of the application, then the status of the defect gets changed to not a bug. So this is complete discussion about the defect lifecycle, guys. If you still have some doubts or questions, then please write your questions in the comment box of this video, and please like and share this video. And if you are new to this channel, then please subscribe this channel and click the bell icon to get the notification for upcoming videos. Thank you so much. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect leakage. So let's get started. So what do you mean by defect leakage? So some of the defects are escaped from one level to the next level of testing is called defect leakage. So what happens is, while doing the testing, as a tester, when we perform testing, so some of the defects are missed by the testing team and found during the UAT testing, which is nothing but the user acceptance testing by the end user. If some defects are missed by the testing team and caught during the UAT testing or in production, if those defects are found during UAT testing or in production, so that is nothing but the defect leakage, because those are missed from one level and found in the next level, right, which are missed during UAT during software testing by the testing team and found in UAT or in production, so that is nothing but the defect leakage. In other words, a defect which exists during testing yet unfound by the tester, which is eventually found by the end user, is also called bug leakage. So this is also called bug leakage, guys. Bug leakage, or you can say simply defect leakage. Defect leakage is the metric which is used to identify the efficiency of the QA testing, that is how many defects are missed, slipped during QA testing. So this is one of the metrics, guys, we used to use this to measure the efficiency of the QA testing. Defect leakage formula. So what is the formula of the defect leakage? How we calculate the defect leakage? So we have formula CD divided by DR minus ID. So what is CD? So CD is nothing but the defects found during UAT testing or in production, divided by defect raised by the testing team minus invalid defect. So defects found during UAT testing or in production, defects found in production, divided by DR, defect raised by the testing team minus invalid defects, multiplied by 100. So let me give you an example. So let's say we found 10 defects in production, or maybe we found during UAT testing 10 defects found by the end user, divided by, let's say, 200 defects raised by the testing team minus 20 defects are invalid in those 200. So that means 10 divided by 180, so it will come around 5.5%. correct guys. So that is nothing but the defect leakage percentage. So 5.5% defects are slipped from one level to the another level, from QA testing to the UAT level, to which is caught by the end user, correct. So ideally if you have like 5 to 10%, that is kind of acceptable, but if it is beyond that, like 15 or 20%, so we need to really think about our QA testing process. We need to improve the process to minimize the defect leakage. So let's talk about like what are the various reasons we used to get the defect leakage and how we can minimize the defect leakage. So what are the various reasons, guys, we used to get the defect which are missed during software testing, which are missed by the tester and found during UAT testing or in production. So absence of proper review process. So this is one of the important point, guys. So when we are unable to do the proper review process, then we miss some functionality. Like we need to do the proper review process while reviewing the test cases or reviewing the complete testing process. So we should do the proper review process, right? In case if you are unable to do so, then we miss some functionality, and the defects will be found in production or in UAT. Another reason could be environmental differences. So sometimes what happens is when we do testing in our testing environment, so some of the functionalities we are unable to test properly, right? And during the UAT testing, the environment is different, so they are able to reproduce the defect, or defect is caught during the production environment. Okay, so that is one more reason. Another reason could be missed test cases. So this is important point, guys. Missed test cases. If we are unable to write the test cases for any particular functionalities, and then obviously if you are unable to test that, then definitely the chances of getting the defect in the UAT environment or production environment will be more. Another reason could be poor design test cases. Poor design test cases. Poor design test cases because of misunderstanding of the requirement by the testing team. So that is one of the reasons. Another reason could be incorrect deployment. Incorrect deployment into production or in UAT environment. In UAT environment or in production environment. So that is another reason for defect leakage. Another reason could be, that is also important, which is incorrect data. Incorrect data. So if we are not able to use proper test data, so definitely the chances of defect leakage is more, right? So we should do the proper testing, and also you should use the proper test data, correct, to test any particular functionality. So these are the various reasons, guys. Now let me just talk about some of the prevention techniques or prevention points which we can using which we can minimize the defect leakage. So the first point is we should do the proper review process. Proper review process of our testing, or proper review of our test cases. Another point is design proper test cases, or we can say the coverage of the testing should be proper. Proper coverage of the requirements, right? So we should understand the requirement well and then write the test cases accordingly, and then coverage should also be 100%. Another point is we can focus on some of the functionalities where the defect leakage chances is more. So that is another point, guys. So focus on modules where chances of defects is more, and we should do the proper regression testing, guys. Proper regression testing to make sure the impact of the functionality in other modules. Okay, so these are the various points, guys, which we should take care while doing the testing process. Okay, while doing the testing. So if you follow this process, then definitely will minimize the defect leakage percentage, right? So guys, if you have more techniques or if you have more points, then you can write in the comment box. And still, if you have any questions, then please write your questions in the comment box of this video. Thank you for watching this video. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic, that is defect clustering, and this is one of the testing principles, guys. So let's get started with defect clustering. So what do you mean by defect clustering? So when defects are found in a group while testing any particular module in any application is called defect clustering, or in other words, when we found group of defects on any particular module is called defect clustering. So basically clustering is nothing but group, right? So let me just explain further. So while testing any application, let me just represent with two axes. Let's say this side represent defects and this side represents modules. So in this application, let's say we have different modules, module A, module B, module C, D and E. We have five modules in this particular application. Let's say we are getting the number of defects, like these many defects for module A, these many defects for module B, these many defects for module C, and more number of defects in module D, and these many defects for module E. So you can see the defects are varying, right, from module to module. Okay guys, and we are getting more number of defects on this particular module D, more number of defects or group of defects in module D. So this is nothing but defect clustering, and it is based on Pareto principle, guys. Pareto principle. Pareto principle. So what it says, or in other words you can say 80-20 rule. 80-20 rule, this is also called 80-20 rule. So what does it means? 80% of the defects are found in 20% of the module. 20% of the module. So here in this case we have 5 modules. So let's say the size wise the module we have divided, each is 20%. 20%, this is also 20%. So the size wise all the modules are same, correct? So we are getting 80% of the defects in 20% of the module. In this case we are getting 80% of the defects in module D. Okay, so this is Pareto principle, or in other words what you can say is we have written the test cases and 20% of the test cases are effective to get 80% of the defects in the application. So this is how you can understand, in other words, okay, 20% of the cases, test cases are effective to get the 80% of the defects in the application. So this is Pareto principle. Now what is the reason we are getting most number of defects in this particular module, right? So the reason could be the complexity of the application, complexity of this particular module. So developer make a mistake while writing the logic or writing the code. So that's the reason we are getting more number of defects in this particular module. Now what we should do as a tester, right? So we should concentrate more on this particular module, and write more number of test cases using different scenarios for this particular module. But we should not forget at the same time other modules as well, guys. We are concentrating on this particular module because this is more error prone module, but we should also test the other modules at the same time. We should also concentrate on other modules as well. So this is about defect clustering. So this is the definition of defect clustering. So when a small number of modules contains most of the bugs detected or show the most operational failures is called defect clustering, or in other words when defects are found in group in any module is called defect clustering. When the defects are not distributed uniformly across the entire application, rather defects are concentrated or centralized across 2 or 3 functionalities. So that is nothing but the defect clustering. So this is about defect clustering, guys. If you have any doubts, then please write in the comment box of this video. Thank you for watching. Have a nice day. Bye bye. Hello guys, welcome back to another video of Automation Testing Insider. So today I'm going to talk about defect age. So let's get it started. What is a defect age? So the time difference from defect found date to defect close date is called defect age. So let's say 20th of this month we found the defect, and in the next month 5th of the next month it got closed. So what is the difference? So here we have 15 days. So 15 days is nothing but the defect age. So this is calculated in days or in hours. When the testing team identified the defect and when the defect is fixed. So the difference between when we identified the defect and when defect is fixed. To know how much time it take to fix the defect by developer. So what is the use of this defect age matrix, right? So to know how much time it take to fix the defects by the developer. So this is nothing but the defect age. The defect fixed date may be the past date on which defect is fixed, or the current date if it is still open or unresolved. Okay guys, so it is not mandatory like when we fix the defect then we can calculate this defect age. If defect is still open state or it is in unresolved state, so till that date what is the difference? So that is again we can say defect age. We can calculate that particular day, the difference between those days, right? The defect age is calculated based on the 2 factors parameters. So there are 2 factors, guys. One we can calculate based on the time, and another one is using phase, software development phases. Okay, I'll explain. So defect age in time. So how we can calculate? So defect age in time is the difference between the time of the defect detection and defect fixing. Means when the testing team identified the defect and when the defect is fixed. Mainly this defect age is calculated in days or in hours, as I have discussed earlier. So how to calculate defect age in time? So this is the formula, guys. Defect age in time, defect fix solve date or current date if it is open state, defect detection date or identification date, the date when we got the defect, correct? So defect fix date, or it is the open state of the defect, the day on which still it is open, right, minus defect detection date or identification date, the day on which we got the defect. Defect age in phase. So how we can calculate defect age in phase? Defect age in phase is the difference between the phases of defect injection phase and defect detection phase. Here the phase refers to the different phases of SDLC. How to calculate defect age in phase? So this is the formula: defect age in phase, defect detection identification phase minus defect injection origination phase, right? So let me just give you an example. So we have different phases in software development life cycle, guys. We have requirement analysis, we have design, then coding, then unit testing, integration testing, system testing, acceptance testing, and maintenance finally, right? So let's say we found the defect in coding phase and it is detected in integration testing. Okay, it is detected in, the defect is originated in coding phase, but it is detected in integration phase, integration testing phase. So here is the formula: defect detection identification phase. So it is identified in integration phase, and defect injection or origination phase, so it is originated in coding phase. So what is the difference? 2, right? So there is a difference of 2 phases, so the defect age should be will be 2 here. So this is how we calculate defect age in phases. So this is all about today, guys. So if you have any doubts, then write your question in the comment box of this video. Please like and share this video, and if you are new to my channel, then please subscribe it. Thank you for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Test Insider. So today I'm going to talk about an important topic, that is defect masking. So what is defect masking in software testing, or what do you mean by mask defect? So we'll discuss about different examples of defect masking. So let's understand first what do you mean by mask defect. So mask defect, commonly known as a defect that hides other defect in the application, is called mask defect. So let me just explain. So let's say we are testing any application and there is a functionality A which we are testing right now, and there is a related functionality called B. So functionality B is related with the functionality A, and there is a defect we found while testing functionality A. So there is a defect in the functionality A, and there is a defect in functionality 2 as well, functionality B. So since we cannot execute functionality B without functionality A, so since we got defect over here, we cannot execute functionality B. So defect 2 is mask defect. So this part will be unnoticed because we cannot execute this part, right? So defect here in functionality B is called mask defect. Let me give some other examples, guys. Usually we used to get defect masking or mask defect in page navigation. In page navigation. So let's say we are testing any application, and in this particular application, let's say this is employee website where we have add employee functionality, add employee, and there is inside, so this is one page, page 1, add employee, and there is another page called add task. So we cannot go to this page, add task, until and unless if we don't execute this page, right? If we don't navigate to this add employee page. So we found defect over here, add employee. We find that we are not able to navigate to this page, add employee. So we cannot go to add task page. So this part will be unnoticed, right? So whatever defect will get on this particular page at task, whatever defects are there which will be unexecuted, or we cannot execute this functional related functionality of at task page. So this is another example of defect masking or masked defect. Let me give one more example. So let's say we are testing any application, and we are printing some page on this particular application, and we have two printers. We have laser printer, and we have dot matrix printer. Now take an example. This is default printer, laser printer. So let's say we are printing any page, and this default printer is we are not able to find this laser printer. Okay, take an example. There is no issue, but we are not able to find this because of connectivity. We are not able to find this laser printer. So what a system will do, it will search for another printer which is dot matrix printer. So there could be there are two functionalities over here. First one is search functionality, search for dot matrix printer, and second one is print the page. Correct. So until unless we don't find the dot matrix printer, we cannot print the page. So defect on this print functionality is called the defect or mask defect here, over here, defect, right? So this is mask defect over here. So this part will be never be executed until unless we don't execute this search functionality. So there is a defect while searching the dot matrix printer. Okay, so this defect will be unnoticed forever, this print functionality of this dot matrix printer. So these are the different examples of defect masking or mask defect, guys. So let's talk about some theoretical stuff, like just recap what we have discussed so far. So when defects are hidden, like one defect may be hiding in the another defect in the application, is called defect masking. Mask defect is type of defect that is hidden in the software and hasn't caused a failure because another defect has prevented that part of the code from being executed. So there won't be that won't cause a failure because another defect has prevented that part of the code from being executed. It is only uncovered when the defect hiding it is uncovered by the user by performing a specific operation. Mask defects are the defects covered by or marked by another defect and can't be identified until the later is detected. So we talked about different examples of defect masking. So guys, this is all about this video. If you have any questions, please write in the comment box. So thank you for watching. Have a nice day. Bye bye. Hello friends, welcome back to another video of Automation Testing Insider. So today I'm going to talk about an important topic in software testing, that is defect triage. So you might have heard the term defect triage meeting many a times. So in this particular video I'm going to talk about what do you mean by defect triage, what is defect triage meeting, why do we need defect triage, and what is the process of defect triage, and who are all the participants of defect triage meeting, and at last I'll talk about the outcome of defect triage. So let's get started. So let's talk about the definition of defect triage first. What do you mean by defect triage? But before I start the definition of defect triage, let's understand the meaning of this word called triage. What is the meaning of this word triage? So in simple words, I would say to decide something, to decide the order is called triage, or I would say to sort it out something, or sorting is nothing but triage. So this is the simple definition or simple meaning of the word triage. Now what is the definition of defect triage? Defect triage is the process to prioritize the defects based on its severity, its priority, risk involvement in the defect with the defect, and last one is frequency. So these are the four factors, guys, Defect triage is the process to prioritize. Basically, in defect triage, we prioritize the defects based on its severity, like how bad the defect is. We have already spoken about severity and priority in previous video, so please go and watch that video if you haven't watched the related to severity and priority. So basically, it talks about the severity of the defect, like to decide the priority, to prioritize the defects. We used to talk about its severity, because we used to decide the severity while logging the defect, right? So we used to talk about in defect triage what is the how severe it is, like how bad the defect is called the severity, like how does it impacts to the functionality, right? So that is severity. How important, what is the importance of the defect is called the priority, like how soon it should be fixed is called the priority. Risk involvement is nothing but the what are the project risk, or what are the business related risk involvement with the particular defect, and frequency is nothing but the occurrence. So these are the four factors we used to discuss to decide to prioritize the defect, prioritize the defects during the defect triage. And why do we need defect triage, right? And what is defect triage meeting? So to evaluate the process, to go about the defect triage process, we used to conduct a meeting called defect triage meeting. Now one question comes in your mind: why do we need defect triage? Why do we need defect triage or defect triage meeting? So the first thing is to prioritize the defect. That is simple thing, right? We used to decide we have to decide the prioritize of the defect. So that's why we used to go about this defect triage meeting. Another point is sometimes we have very less time to fix the defects before the release, and we have more number of open defects. So that's the reason we used to conduct this defect triage meeting. So this is the reason, guys, we used to go for a defect triage meeting. Now let's talk about what is the process of defect triage, or what is the process of defect triage meeting. So basically there are three stages in defect triage. We firstly we decide, we review the defect review, and the second thing is defect assessment, and at last defect assignment. So what do you mean by defect review? So first of all, we review all those defects, all those open defects, and then assess the defects based on we'll discuss about the root cause of the defect. So there are few things like root cause of the defect. Second thing is the complexity, like how complex it is, like technicalities of the defect we used to discuss. And the third thing is business impact, how does it impacts to the business of the to the business, right? So these are the three things which we discuss during the assessment of the defect to decide the prioritize, right? So we have to discuss about all these points, like root cause of the defect, the complexity, whether we can fix on time or not, and then business impact, how does it impacts to the business. If it is very important, then we have to give a higher priority to the defect. And last thing is defect assignment. We have to assign the defect to particular developer, particular team or particular developer to fix that defect. So these are the three stages of defect triage: defect review, defect assessment, and defect assignment. Now let's talk about who are all the participants of defect triage meeting. So in defect triage, generally we have project manager, and then we have technical team lead, development team lead, we can say team lead, TL, development team lead, and then we have test manager or test lead, So these are the participants guys, and some optional and one more business analyst. So these are the participants of defect triage meeting. Or optional are development team and testing team. So in many companies, they used to conduct defect triage with development team and testing team. They involve these members as well, but generally it should conduct like in general process we have project manager and the development manager, development lead, test lead and business analyst. So these are the participants of defect triage meeting. Now let's talk about what is the outcome of defect triage meeting. Outcome of defect triage meeting. So basically when we have gone through the defect triage, so we used to have the following information. The outcome, I would say, defects are identified, right? All the open defects are identified. Second thing is severity and priority are decided. Third thing is assignment or assigned to particular developer. And status, what is the current status of the defect, and what is the resolution date. That is important. Date of resolution is important. And then time taken to resolve the defect, or how much time it will take, right? So time for fixing the defects, and last, time taken to fix the defect. So these are the outcome of defect triage meeting, guys. So this is all about defect triage. So let's talk about, I have written some of the other points as well, like some simple definition, like I would say the recap of defect triage. Defect triage is the process to prioritize the defects based on severity, risk, frequency of occurrence, which we have discussed about. If more number of open defects and less time for fixing, a meeting is conducted by project manager, developers, tester and business user to identify the defect which are possible to fix and which are not. Okay, so this is the main idea behind a defect triage meeting. During the defect triage meeting, each defect is analyzed to see whether right priority and severity are assigned to it. Priorities are rearranged if needed. So generally, right, I mean when we log the defect, then we used to decide the severity and priority, but it should be correctly assigned during the defect triage meeting. So these are the different points I wanted to discuss about defect triage meeting, guys. So let me know if you have any questions. Comment your questions if you have any, and please like and share this video. And if you are new to this channel, then please subscribe to this channel. Thank you so much. Have a nice day. Bye bye.